DCV valve or a directional control valve having 4 ports and 2 functions. So today we will see logic type of DCV valves, and we will cover a 4-3 DCV valve. Okay, and we'll try to touch upon sequencing. Let's see within half an hour we will be able to do that or not. Okay, so first we have this 4-3 DCV valve. Yeah, so as I told you, 4 represent the port and 3 are the position. So in 3 here we have 3 position. One will be retract, one will be off, and one will be extend. So let's say we have a piston cylinder assembly which is connected to a DCV valve, and it is a double acting cylinder. Okay, so we have a port B here. Sorry, port should be in DCV. So we have port A, B, then we have P port, and we have pressure port and retraction port. Okay, and so the basically it is having 3 function. So R, that is retract, off, and extend. Okay, so how this sequencing, how this function, how this valve work, if you consider extend, so we will be focusing on valve only. So to extend, what it will need to be done, this pressure port should connect with A port so that pressure will be supplied here, which will result in the extension. So a connection between P and A will be there, and B and A will be there. Sorry, B and R. Okay. Now, if you are going for off position, so A and B are close, and there is a connection between P and R. You can draw here or you can draw here. Okay, so here this particularly used to clean the wall. Okay, and if you want to perform a retract function, so you have to connect pressure port and B port. So when pressure port and B port will be connected and A and R will be connected, what is happening? If this is connected, here the fluid pressure will be exerted and it will result in the retraction. Okay, so this is how your 4-3 DCV valve works. Okay, also we have spool type DCV valves. Okay, DCV valves, particularly spool type. So here we have a horizontal motion of spool. What we have seen till now, the opening and closing is controlled by either a ball disc movement, because we are using a poppet valve. But in few cases we can use spool valves, which utilizes the horizontal motion of spool, which governs the opening and closing of the port. So basically your spool, if you see this piston cylinder assembly, spools will be a block. Okay, these are the blocks which is loaded by spring. Okay, then this is connected to, let's say, another spool. This is one port. You have one port here. Okay, okay, and one port here. Okay, so basically port opening and closing is governed by the horizontal motion of this spool. These are spools. So the horizontal motion of spool will determine the opening and closing. So we generally use 3-2 spool or 5-2 spool. Okay, so yeah, so these are poppet valve that we have covered. So this is a 5 to wall which is having a spool. Okay, so this is spool. So we are having 5 port. Okay, P, R, S and A and B. So 5, and it is performing two function. Okay, extend and retraction. That is why 5 to wall, but this is a spool type. Okay. Next is your DCV valve as a processing element. So as we covered that DCV used for sensing, okay, processing and power element. So next is your processing element. Coming to the sensing, the sensing of DCV, this is all is sensing of DCV, and this sensing is uh, governed by the action of one button, that is push button. Apart from that, we use other type of button also. I will show you in the symbol. Okay, so through the position of this push button on off, this DCV valve sends the signal and it will operate. So DCV valve as a sensing unit. In case of processing unit, in order to process, this have to follow certain logic. So we call it as logic valves. Okay, so basically what it will do, it will generate, it will cancel or redirect signal based on the logic values. So logic values in generally, in case of electrical or electronics, we have 0 and 1. Okay, so on the base of this 0 and 1, we create logic gate. Okay, so or logic gate and logic gate, nor XOR, like that, but we generally deal with here or and type of valve, which basically works on this two principle, or and system. Okay, so first we will cover or. So if you see the function of or, so you have or gate symbol. Okay, so this is your output unit, this is your input A and B. Okay, so you can either have 1 0 1 0, like 1 0, or combination of this. So basically your or will do. So coming to the input signal, let's say you don't have any signal at the input. 0 0 means your output will be 0. When you are having 1 0, so 1 plus 0 1 0 1 1 0, sorry, 1 1 1. Okay, so this is how you, means if there is input in any of the port. Okay, if there is input in any of the port, the valve will operate. Okay, the valve will produce the output. Okay, so that is your or valve. Okay, so if you see the schematic diagram of or valve, okay, so you have, this is simplistic or valve. Okay, so this is your slider. Okay, when you have a signal from this port, let's say this is B, signal from this port 1, so what will happen? Due to this pressure, this piston will move and it will close A. So at A, the signal will be 0, but the output, which is your C port or output port, this pressure will be transferred through this and you will get a output. When you have a signal at A 1, so this will slide here. Okay, so at port B, the signal will be 0 and it will transfer the output to C. So hence it will be satisfying the situation. Okay, and whenever there is a signal on both, like A and B, so basically it operates on pressure difference. So it will be closer to any one of the port, means it will, let's say I will, this is A, this is B. So let's say we have a pressure P1 that is input at port A and P2 input at port B. So let's say P1 is greater than P2. So what will happen? The position will be somewhere here. Okay, not close to this, but somewhere at a distance. But it will be sufficient enough to close the input from the B port. So you will have a output still here in form of one. So one, one, and one. That is how your OR gate is, or valve is operating. And if you see the symbols, okay, the symbols are very much important in cylinder sequencing. So you have to be very careful about the symbols, okay, while whenever the question will come, you have to very specific about the symbol. You have to draw the right symbols while doing the sequencing. Anyhow, you will draw a right symbol because exam will be online, so you will be having sources, so through that you can do that. But still, I suggest you to go through the symbol chart. I will be sharing with the in this presentation. Then we have and. So and will work on this A into B. So O or C. So basically 0 0 0 1 0 0 0 1 0 1 1 1. So whenever there is an input in both the port, then only your and valve will operate. Okay. So let me show you the schematics of this one. So this is the directional valve as a signaling element. So through any of this signaling element like lever, roller, switch, spring, okay, you can supply the signal to DCV valve. So generally we have this push button. So whenever you draw a DC valve, you can draw this push button showing that the signal is transferred to the DCV valve from this particular signaling element. Okay. Then we talked about OR. Okay. So this is how the OR construction looks like. Okay. Now coming to the AND. So this we have discussed already. But here you can see, okay, this schematic is not correct. It should be somewhere here. This, okay. I have taken from the book, but this is not correct. If you have signal from this point, then only it will transfer. Otherwise, this spool position will block one of the port and finally the output. Okay. This is the power element. This is a repetition of previous that 5 to spool valve. Okay, but how this it is acting as a power element. Basically, it is connected to the cylinder and it will transfer the fluid energy to that piston cylinder assembly. So you will understand this in more better way when you will cover the sequencing. Okay, so this is a solenoid operated DCV valve, means the signaling is given with the help of a solenoid. So what will the solenoid do? When the current passes through this solenoid, it will get excited and it will result in the mechanical motion. Due to this mechanical motion, this solenoid will make the connection and it will result in the opening and closing of the port and result in the actuation of your valve. Okay, so generally, for your in your cylinder sequencing, we will be covering push button type DCV valves. Okay, but this solenoid valve, we will cover one question so that you can understand this how the solenoid valve is actually working. Okay, so before going to the cylinder sequencing, it is very important to understand the symbols, that what symbol sketch need to be drawn in order to create a pneumatic or hydraulic circuit while designing any mechatronics system. Okay. So basically symbol is used to display certain characteristics like function, actuation, okay, number of connections, switches we are using, what flow path will be there. So it can be realized with the help of these symbols. Okay, but the symbol are not the real representation of size and dimension. It will not tell you about which manufacturer it is, because it will be a generalized circuit diagram with the help of symbol and characters. Okay, so it is not related to any particular manufacturer. and also it will not provide you any physical detail that what power or what input or what current voltage is acting as an input to operate the system. Okay, so basically we use letter system, that is ISO system, and also we use number system. So as per your convenience you can use any of this. Okay, any of the uh, symbol system. Okay, so P refers to pressure port, working port. B is also working port. R is exhaust. S is exhaust. Okay. Any pilot port will be there if it is operated by a pilot valve. Okay. And likewise, we have number system. But I will suggest you to stick to one of any one of the nomenclature so that it will be easier for you to design a system. Okay. So these are the symbol which we generally use. So if you are using any pneumatic system, so there you have air compressor which will be acting as a which will act to, or which will be a source of high pressure air. Okay, so this compressor symbol will be like this. Then you have hydraulic pumps symbol. Okay, so for hydraulic pump, you have one direction, two direction rotation. Okay, with this point you can show. Okay, and if this arrow sign will be there, then it will be having a variable displacement. Okay, likewise, any service unit like air filter, lubricator, dryers, okay, or any other cleaning component which is required to clean the air or fluid from the impurities. Okay, so this can be these are the symbol which need to be used. Okay, but see, in my case, you can use your circuit diagram need to be correct. Okay, if you are not using any this service unit or anything, it is not important, but you should be very careful about this hydraulic pump and compressor. So in question you should be very careful that what circuit you need to draw. Okay, so these are the symbols for directional control valve. It is 2-2 valve means two function, two port, 3-2 valve. Okay, 4-2 valve, 4-3 valve, and 5-2. So for your convenience, you should remember these symbols. Okay, these three symbols are very important because most of the hydraulic or pneumatic circuit will be using any of these three. Okay, and in actuation I am not very restricted about actuation. You can use any of this one, but if you will use push button or you can use spring actuation. Okay, any actuation system you can use. Okay, but this symbol you need to understand, these are the symbol. Anyhow, when you are referring in any real time situation, this symbol chart is available to you so that you can understand which type of actuation method is used for the directional control valve. But in our case, you can stick to push button or spring actuation. Okay. These are pressure control and pressure. So these are extra element which are required. Okay. Apart from fluid flow, we have to relieve the pressure. We have to be very sure about that the pressure in the uh, hydraulic or pneumatic line should not cross the upper limit. Okay, and likewise we have to have unloading valve to remove the excess liquid towards the sump. We need to have a counterbalance valve which will control the free fall of the weight. Okay, so these are the symbols. Okay, so we'll start with a simple cylinder sequence, okay, which is a single acting cylinder extend upon the operation of push button. So it is actuated by a push button for transferring a part from a equipment. Okay, so the cylinder remain extended position as long as the push button is activated. So actuation is carried out with the help of a push button. Okay, and piston will retract as you release the push button. Okay, so you have to design a pneumatic or electro pneumatic. So this is not important. You have to design either pneumatic or you can draw hydraulic circuit for the application given. So here it is asked pneumatic, so we have to draw a pneumatic circuit. So basically you have a single acting cylinder, means you have a single port here, okay, and another one is you have a directional control valve which is actuated by a push button. So you can draw a directional control valve. It is um, it is controlled by a push button, okay. So in order to govern the opening and closing of port, this push button will activate what? Spool, okay. Either spool will be here or here, that we will decide, okay. So how it is working, that it is extended when push button is pressed or activated, means it means we have to supply from the pressure port, okay. Extension will be in this direction, so we have to supply from the pressure port. So when push button is activated, your piston position will close the will open this pressure port, okay. So means when push button is activated, the connection will be in this direction, we will draw here. So connection will be this, okay. And your this two port B and R are closed, okay, with the help of a spool, okay. So how the circuit will look like? So initially we have to retract the cylinder so that we can remove or expel out the gases. So our first will be retraction. First retract. So in order to have a retraction, what can be done? You can use a single port here or a double port. It's your wish, but as it is a single acting cylinder, you can use a 3-2 DCV valve. Okay, 3 port 2 function. Okay, so this port will be connected to the extraction. The direction will be here. During extraction, your R wall should be connected. Okay, so this is connected, and your spool position is here. Means P is closed. When you will push the button, it will get activated. Okay, so you have a compressor here. Okay, compressor to supply the high pressure here. So when push button is activated, what will happen? Actuation. In actuation, when push button is activated, so your pressure line will be in connection with the input port, and it will result in the extension of the cylinder. This is P, this is R, and this R port is closed. This R port is closed, and it is connected to a compressor. So this is how your circuit will work. And if you want to draw the circuit diagram, how the circuit diagram will look like? You have push button, you have R here, P, R, okay, A, and this is the port extent. So this is a simple pneumatic circuit of a single acting cylinder. Okay. Likewise, you have a conveyor belt which carries the finished product. It's a double acting cylinder used to transfer a station to remove the finished product from the conveyor belt. When push button is operated, means when push button is operated, it will remove the finished product in actuation, and at the point where push button is released, this it will return to its original position, means retraction. So you have to draw a design a pneumatic circuit. So it's a double acting cylinder. So for a double acting cylinder, uh, you in order to act in both the direction, it should have a two ports, two input. So in order to connect this two input, you can use a 4 to DCV, which will be having 4 port and two function, that is extract and retraction. This is your pressure line. This is your release. Okay, and it can be actuated by the push button. Okay, so when push button is activated, it will transfer. Means push button is activated means pressure line and A should be in connection, and this port will be closed, or through this port your gases are released. Okay, so this is how. Sorry, I'll cross this. So when push button is activated, your pressure line is connected. Sorry, pressure line is connected, A and P, and this port is closed. That is B and R. Okay, so this pressure line, so it will result in the extension. Okay, and when your push button is released, so what will happen? This line will be closed. Sorry, yeah, here I can go. So when push button is released, so your pressure line will be closed. Your pressure line will be closed, P and A, push button, and your B port and R port is connected. It will be expelled to the atmosphere, and the cylinder will be releasing. Okay, this cylinder will release. Okay, so I think yeah, so this is some other thing. This is double acting cylinder. So likewise, design a hydraulic circuit for a furnace door open and close. Figure show the schematic. So with the help of push button, when you will press a push button, this furnace door get activated and it will lift. Okay, and when it is released, it will come back to its original position. So this is how a circuit diagram will look like. Okay, so it is having a pressure relief valves. Okay, at different positions, or safety valves. But if you will draw without it, it's fine for me. But the circuit should signify the proper functioning. So here we are connecting it to a sump. So we are using a hydraulic system. So this port will be connected. Okay, A and B are connected, and it will come back to its position. Okay, and these are the pressure release valve. If pressure in the line is high, so it will be released towards the sump. Okay, so in more detail we will cover this. Okay, and you might be wondering that how this sequencing is important and how this is working. So this is a sequence of clamp and bending which can be used for drilling. Okay, which can be used for the drilling and clamping function simultaneously. Okay, so how this is working we will cover in more detail in our next class. Along with that, we will cover sequencing with the help of a logic valves. Okay, so I think we can, yeah, if you have any doubt you can ask. Okay, so I think I can close the session, Kalyan.
Yes, sir.
Okay, and I will upload this PPT in Google Drive. Okay,
Okay, sir.
Kalyan, if any PPT or anything will be left, you update me. Huh?
Yes, sir. I will update you.
Okay, 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 bye all, take care.
Thank you, sir.
Thank you, sir.
Thank you.